click on record already.
Okay.
Great. Wonderful. Thank you so much,
Yeah.
Adrian. Okay, so hello and welcome everybody to this webinar about exponential technologies in robotics. This is organized by DIH². I am Alex. I'm head of communications at ISDI, a Spanish business digital school. In this webinar, I'll introduce you the DIH² network, our purpose, and then I'll go through a resource that we're offering to you and to different users and experts and interested people that we're offering to everyone as part of the DIH² services. It's the MOOCs, free online courses about technical and digital skills designed to be useful for SMEs, individual working in manufacturing and robotics. So after that, I'll hand it over to Adrian. He's our guest expert, and he's the creator of this first MOOC course about exponential technologies in robotics, and he'll take you through the key points of his course and everything you need to know about the topic. And when he's done, we'll just have a few minutes for Q&A. So yeah, let's get started. If you want to go to the next slide, Adrian, please. So DIH DIH² believes in the power of robotics to transform the agility of manufacturing in SMEs and to drive economic growth across all the European Union. Our role is to facilitate the connections that will enable agile production in factories, where speed and versatility are essential to satisfy customer demand. So originally was funded by Horizon 2020, the European Union Funds Research and Innovation Program. This H2020, like bringing great ideas from lab to market, and we aim to generate innovation that maximizes productivity and optimizes agility in manufacturing SMEs and mid-caps across the European Union. Apart from that, our goals include improving the cost effectiveness of advanced robotic solutions and driving growth of the robotics market. So we actually already have a very large ecosystem that's been going on for a few years. It's several organizations that have joined our network. And if you're interested in learning more and joining, you can visit DIH/squared.eu. If you can go to the next slide, please, Adrian. Thank you. So DIH² is managed by a number of different partners that we're all across Europe, and each playing a very different and specific role. And as I said, myself and my colleague Alvaro, who's also here connected, was just having some technical issues. We're both from ISDI, which is a business school for the digital era based in Spain. And our role is to provide training courses that are currently open and free for anyone to access and learn from. Next, go, please. Slide, not go. The objectives of the course are, as you can see here, like we aim to introduce users in the European manufacturing sector to new technologies and ways of work, to teach how to implement those ways of working, and to ultimately support the update of innovation in manufacturing SMEs across Europe. So you can view all the courses that we've put together online in an online platform. The link DIH slash, what is that slash? Not a slash, line squared.mooc.ramp.eu. And you can browse there our entire catalog. We've got, many courses. You can browse at the beginning without registering, but if you do want to take a course, you will have to create an account so you can access all didactic material. And it's pretty easy and straightforward, no weirdness around it. If you want to go to the next one, you will also see that we have a number of courses specifically focused on technology related to manufacturing and robotics. It's a little screenshot of what you would find. And here in the next slide, you can see the list of, a better overview of what we have on that list in the platform, and the names of the different experts that have worked on the different courses. And finally, in addition, like we have a wide range of courses about digital skills that basically are aimed to help you bringing your knowledge into the modern world. So topics covered include agile methodology or data-driven marketing, interface design and usability, and many more. So all of our courses include and feature video, text, slides, graphics, interactive learning experience, and many courses will also allow you to test your knowledge at the end of with some self-assessments. The length of of each course, the time that it takes to complete a course may vary from 1 hour to less or up to 10 hours. So it basically depends on the topic. And again, in the next slide, I'm just leaving here the URL, but I'll make sure to send the URL to all of you guys in an email after this session. And yeah, now I'd like to introduce you to Adrian. So he's our guest speaker for today. He's CEO of Dronomy and lead data scientist at Shapelets, and as well he's being a guest lecturer at IE University. In addition, he has got a lot of experience as a researcher and CTO for many different technology companies. So thank you so much, Adrian. You're here with us today. You'll be talking about exponential technologies in robotics, and we're very glad to have you here. Thank you. So please,
Thank you.
You may go for for what everybody's
Okay.
doing.
Thank you so much, Emily, for the for the nice introduction. And yeah, I would like to start by well, I'm very grateful to DIH and also to the is the team for to put together this course and well for helping with its production and to take it to the place where it is right now. So basically the contents of you can see my presentation, right?
Yes.
Okay,
all good.
Thank you. Yeah, so the contents of my presentation will be the following. I will start with a short introduction and what motivated us to build this course. It's basically a course that covers a bunch of emergent or hype, if you wish to call them so, technologies. And we want to basically understand their relationship with robotics, which itself can also be considered an emerging or exponential technology. And so I will try to cover very briefly, because I think I have 30 minutes. I will try to cover very briefly, what these technologies are, if I have the time, and if not, I will just let you know what you will learn about each of them. But basically, it's going to be like a soft introduction to a different set of very relevant technologies today. And before I finish, I will also talk about the robot operating system, which is the most relevant, in my opinion, software framework that we have today to build software for robots. So I'm sure all of you have read headlines like this. So Walmart will train employees with virtual reality headsets. Google's learning software learns to write learning software. Hyundai is the first automaker to launch an augmented reality owner's manual, or Google achieves quantum supremacy. And sometimes, if we are not familiar with these technologies, we might not understand what this is saying. So the idea is that this course will help you get closer to these technologies. And the idea is also to promote interest and curiosity in general about technologies we're not familiar with. So I'm a strong believer that innovation arises from the intersection between existing technologies. So this is basically going to be a broad spectrum and I would say high-level course on modern technologies. It's a course that lasts, I think, a little bit more than 2 hours. So you can imagine, the level of detail that we can go into. I don't know if you guys are familiar with the Medici Effect book. It's a book written by this guy, Franz Johansson, who is an innovation expert. And well, he basically talks about the fact that there are two ways of thinking in terms of innovation. So one can think directionally, which means like thinking inside the box, like within your industry, and like trying to think everything in a little bit in the same way, as opposed to try to learn from different fields and try to find these intersecting ideas. And in his book, he gives this example of this architect who studied how termites build their homes, and then based on what he learned, he was able to design a building in Africa with no air conditioning. So in the end, the idea is to try to be in, let's say, an area of discomfort with respect to technology. So to try to approach what we don't know and try to understand what we don't understand well, because that's the moment where you might be able to connect some ideas and find that click moment that he talks about in his book, the Medici Effect. I strongly recommend it. So I think it's also we're living a quite exciting moment for technology lovers like me. I think it's the speed at which innovation is moving today is way more different than in previous technological revolutions, and that is also the reason why we need to be able to move fast at grasping new technologies. And one thing about these hype technologies or emerging technologies is that some of them end up, just being expectations, right? So it's important to be able to determine whether a hype is real and is going to value or not, right? So Gartner does a great job at this, and every year they produce these and other visual representations for innovation, and they also have one of these charts for individual technologies to see where each of the areas within, for example, deep learning is moving towards. But basically what this allows you having a good understanding of where the technology is at a given moment in time, is that it's going to help you avoid things like adopting a new technology too early, or giving up too soon, or adopting it too late, or maybe hanging on too long to adopt a given technology, right? So we're talking about 3 to 5 year cycles, and it's important to be where we need to be. So we basically can distinguish like 5 areas in these charts. I'm just going to describe them very quickly if you're not familiar with them, but basically we have this innovation trigger at the very beginning, where products or technologies start to enter the market, and there is this technological breakthrough, and products start being launched, and startups start to emerge. Then we have this peak you know, at the very top, where, you know, there is starting to be a number of users and a number of providers of the technology, and there is hype, but still there is like limited proof that the technology will actually be providing a, you know, tangible value. Then we have this slope down. It's called the through of disillusionment, and, you know, that's where people find out that your technologies, you know, might have some performance issues, or some low ROIs, and you know, then there is like this disappointment, right? Then we have the slope of enlightenment, where early adopters start to see some initial benefits and start to understand and how to adapt innovation to their organizations. And finally, we have this plateau of productivity, where innovation goes mainstream. So, like I said, it's important to identify in which phase we are to avoid you know, problems in terms of, you know, when it is incorporated. So now let me talk about the importance of robotics. Well, we all know it's a very relevant technology today across all industries. But we know it mainly due to its relevant role in manufacturing processes. And also we have in this course try to emphasize you know, its importance in manufacturing. The idea is that robotics can help us understand, can help us obtain high quality standards, optimizing effort, time, and waste. And it can be applied in all stages, right? From production, assembly, repair, maintenance, and even training. And we can apply robotics typically in tasks that they are called 3D tasks. So dull, dangerous, or dirty tasks. And at the end of the day, the objective of automation is to have teams of people working together in very precise ways while being fully integrated with the very best of technology. And another relevant aspect of robotics is the fact that we are today in a society that is overaging. So we actually need to have higher degrees of automation in order to support the lack of human workers that we're going to see in the coming years. So that's why robotics are so important today. And the reason for studying exponential technologies is that those exponential technologies are going to make robots more mobile, more flexible, and more organizing, and more self-organizing. And we'll learn how this actually happens in this course. So I will start talking about the first technology, one of the most relevant ones today, deep learning. We all are familiar with, you know, the use of big data, predictive analytics, recommender systems, and chatbots, and we all have ChatGPT in our head right now, so I don't need to talk about that. And at the end of the day, and when we see it in you know, the relationship between deep learning and robotics, basically robots need to learn with more and more data available to them, and they need to operate in more and more complex scenarios. And that's why deep learning is so relevant in robotics. So in this part of the course, you will basically learn the reasons why it is a hot topic today, to understand how the different AI modalities operate at a basic level. And we learn also, you know, the differences between AI and machine learning and deep learning, which so commonly get confused. And we'll also cover some innovative applications of this technology. We've also all heard about the relevance of quantum computing. Sometimes it's not easy to understand what's under the hood, because this technology is particularly counterintuitive, or some of the quantum effects that this technology relies on are quite counterintuitive. Particularly, there are three unique properties that are superposition, coherence, and entanglement, which are key to explain why quantum computing is so relevant. And you learn what these three properties are in this course. And you learn about the applications of quantum computing in robotics, because there are a bunch of applications. Applications in robot vision, applications in trajectory planning and kinematics, and also the intersection between quantum computing and deep learning, which is quantum machine learning. Blockchain is, another hype technology that is in our heads all the time. It's in the news all the time. I describe the process very briefly here. So basically, it's an information store. Okay, it's an information store that has three properties. It's secure, it's anonymous, and it's decentralized, and it allows to basically run transactions and manage transactions. And the process can be described as simple as with these 6 steps. So basically, the user requests a transaction, then a block that represents that transaction is created, then that block is distributed across nodes. All the nodes will validate the block and the transaction. The block is then added to the chain, and that allows the transaction to be verified and executed. So in this course, we'll cover the process more in depth. We'll learn how this technology operates in more, and we'll also learn some of its vulnerabilities. The Internet of Things, it has experienced an explosion due to an increased computing capability of small electronic devices and microcontrollers and small embedded computers. It's a very interesting technology because it's very simple to use and to develop IoT platforms. So that has also caused it to become mainstream. At the end of the day, these low cost and highly available devices simplify a lot the access to the Internet of Things. And we learned that we need 4 components in the Internet of Things, which are physical devices, data, software, and connectivity. And we'll also learn some specific applications of the Internet of Things. We'll also cover virtual reality and augmented reality. So these are subsets of this virtual reality continuum chart that you see at the bottom. So basically, we go in this chart from real environments to virtual environments, and in the middle we find augmented reality, which is basically placing virtual objects in a real scene in front of us, and then augmented virtuality, which allows us to see and to interact with real objects in virtual environments. And we'll learn about how this, how we can go from real environments to fully immersive virtual environments, and we'll learn applications of this technology and applications that are related to robotics, for example, in robot teleoperation. 5G networks are also, in our minds today. They are very, very common. As every day we have more and more communication modalities. There's email, there's phones, there's video conferences, there's social media channels. So we we have more modalities, we also have more devices, and we are sending larger amounts of data. So this basically demands faster and more efficient and more robust communication technologies, and that's the case for 5G networks. 5G networks in robotics are quite relevant because they allow robots to operate in real time, and they can even, with the latest standards in 5G technology, allow for indoor localization with high precision, which is a topic that I have been researching personally for a long time. So I think this chapter, or this part of the course is going to be very interesting. It will allow you to learn how infrastructure allows for wireless communication. It will allow you to understand the different types of interferences that you can find out there in the real world, and how to deal with them using different solutions that 5G has come up with. And you learn the main concepts and features of 5G. So millimeter waves, small cell networks, beamforming, full duplex, and all these concepts. And we'll also talk about applications in drones, in industrial automation, and in autonomous vehicles. Of course, rapid prototyping and not just 3D printing, but other manufacturing technologies. Rapid manufacturing technologies are very relevant today. They allow us to build robots fast and to prototype in robotic development, and they are also intimately related with soft robotics. And in this part of the course, besides learning about individual rapid prototyping technologies, we'll also learn how hardware products are developed at a high level, and what these hardware development phases are. And like I was saying, so soft robotics are every day more relevant. And that's because some robots cannot work together with humans because they are dangerous, basically. So, we can use torque sensors, for example, in order to provide robots with more sensitivity, but still robots have problems to handle non-rigid parts or fragile parts, fragile objects. And that's where soft robotics, start to become relevant. Also, some robots can be manually guided by the user in order to learn the movements they have to do. So the use of soft robotics is very relevant when there needs to be an interaction with the human. And so in this part of the course, you will learn how these robots are actuated and what their applications are. And particularly, there are several relevant applications in biomedicine that have to do with things like prosthetics, implants, and assistive robots. So after covering all these technologies, and like I said, I didn't want to finish my presentation without talking about the robot operating system, or ROS. Like I said, this is the most relevant framework today for robotic software development. The way ROS works is basically a set of distributed nodes with communication channels that connect them. And so each of these nodes is typically a process that handles a task in the system, in the robotic system. So it can be either reading data from a sensor, making a mathematical computation, determining the speed of a ground robot in order to move to a certain waypoint. So a bunch of different tasks. And we learn about ROS2, which is the The newest version of ROS is the current standard, and it provides higher flexibility, security, and robustness as compared to the initial version of ROS 1. I also want to talk about Gazebo. It's a basic tool for robot simulation. It's typically used in conjunction with ROS, and that's what I want to mention it because it integrates so well with ROS. Sorry, and so it allows to simulate all kinds of robots operating environments, and it can be used in order to test the performance of algorithms before we deploy these robotic solutions to the real world. So just to finish, like I said, this course aims to be an introduction to a bunch of different technologies, their relationship with robotics, and the idea is to provide you with relevant and up-to-date content. We will provide just the necessary level of technical detail for you to understand the principles of technologies, and the idea is that you can get an interest for the technology, and then do your own research and go deeper. And actually there are videos and bibliography that is provided together with the contents so that you can go out and learn more. The course is also very much application oriented, so you will learn about all the different applications of these technologies. And also I will cover some applications beyond robotics, things like drug discovery, medical training. There's applications in finance. There's applications that have to be with smart homes, wearables, remote surgery, a bunch of different things. We'll talk about them. And so yeah, it will basically allow you to go as deep as you want in what you find interesting. So I find it, as a technology enthusiast, I find it a very fun course to take. So I invite you to learn more about it. Okay, so thank you very much, and thanks again for having me.
Thank you so much, Adrian. That was great. Short and sweet. So now we have time for a few Q&A. I know some of you had questions. I am going to activate the audio. If any of the attendees want to put their mic on, please feel free. And if not, just write down the question and we can read it. So yeah, they were asking before also if the courses were for free. Yes, all courses offered, under the MOOC concept, and especially these in the DIH², they are all for free. You just need to register to the platform, and that's it, and you can access all the different courses. Sorry, I can't remember who had their hand raised before. Please, go ahead if you still have the question. Or maybe not. Maybe they just want to go directly to doing the course, Adrian.
That's great.
Yeah.
Good to hear.
Yeah. Okay. Well, if there's no questions, that's absolutely fine. Thank you very, very much. Well, Adrian, thank you very much for everything, for all your very hard work.
Thank you, guys.
For this time.
It's been a pleasure.
Good. Thank you so much, Adrian. And thank you everybody that's connected today. We will be sending you the recording of this webinar and the link to the next webinar is happening, in case you also want to get a sneak peek of all the different courses that we're offering. We'll be sharing everything via the ISDI accelerator channels, as well as from the DIH² channels, so you can follow us there and find out about DIH² and many other opportunities and stuff that we all have going on. And yeah, you know, hopefully see them in the next webinar. And thank you for everything, Adrian. Hope you have a nice day, everyone. A nice weekend. I think we all deserve it. Oh, wait, there is a question. Okay, there is a question actually.
Yes.
And maybe Adrian can answer. What level of experience is required for taking the course?
So I've tried to explain you know, all the concepts, trying to use a, you know, no mathematical language at all, and basically provide you know, an easy approach to the contents, a very intuitive approach to the contents. So there are no priors required in terms of, you know, having a technical background or anything like that. So it should be easy to, you know, for everyone to follow.
Okay. Okay, fine. So if that's it and I'm not missing anything, okay, I think I'm not. We'll wrap it up, and yeah, thanks again. And I hope to see you all maybe next time in the next webinar. Okay.
Okay, fantastic.
Bye.
Thank you. Bye.